Welcome back to Turning Point classes. In this session, I discuss the second level questions of the second chapter of second PUC, that is electrostatic potential and capacitance. Let us start. The first question is three charges capital Q, small q and q are placed at the vertices of an equilateral triangle of side L. The net electrostatic potential energy of the system is 0. Then Q is equal to 4 options are given. See, for this question, recall the equation for electrostatic potential energy. So if you are given two charges, potential energy is given by potential energy, I take it as U. This is equal to 1 by 4 pi epsilon naught Q1 Q2 by R. There is a formula available to us. So when two charges are separated by a distance R, the potential energy U is given by 1 by 4 pi epsilon naught Q1 Q2 by R. Now I am given three charges. So three charges are given. Diagram is not required, just for understanding part I will put it. So here three charges are given to us. So one charge is capital Q, another is small q, one more is Q. So here this is a system of three charges. Potential energy is a scalar quantity. So what is the potential energy between charges at 1 and 2? So what is the potential energy between charges 2 and 3? What is the potential energy between charges at 1 and 3? So three vertices are given. 1, 2, what is the potential energy? 2 and 3. Between these two, what is the potential energy? What is the potential energy here? So just we have to add it. That is the method what we have. That means 1 by 4 pi epsilon naught. Here I have given Q into Q, Q into Q, Q into capital Q into small q divided by the distance here it is given L, that is the side, divided by L. So this is the potential energy between 1 and 2, charges at 1 and 2. Potential energy between 2 and 3, potential energy between 3 and 1 you have to write it. Afterwards you have to add. See, in all these three terms we find 1 by 4 pi epsilon naught common. Therefore I will put it outside. So that I put it outside. Q by L, then I take these two. If I take these two, I will get Q into Q square by L plus Q into Q by L. So potential energy, this is the formula. So Q into Q divided by distance. Then I take these two. So this one is Q into Q. So Q into Q divided by L. So this is the potential energy what we have. The net electrostatic potential energy. So electrostatic potential energy of the system is this is given as 0. That's all. Rest of things is simplification. So I have written 1 by 4 pi epsilon, and the moment it is 0 you could have dropped it. Since we are doing for the first time, I have just written for your easy understanding. Transfer this 4 pi epsilon naught to right side, that becomes 0 into this one, that is 0 itself. Even denominator L you take it as common, send it to right side, that also becomes 0. Now we are left with Q into Q plus Q into Q plus Q into Q, numerator part. This is equal to 0. Q. So if we divide by small q, this cancels. We will be having Q plus Q is equal to 0. So 2Q is equal to, transfer this to right side, minus Q. Q is equal to minus Q by 2. So this is the answer for our question number 1. Minus Q by 2 is existing in option B. That is the answer. Easier one. You should be able to do it just recalling the formula from your mind. Then immediately this one. In just 10-15 seconds you can do it. Now we will take the next question. In the next question we are given 4 charges of magnitudes 2 by 3 Nc, minus 8 by 3 Nc, 2 Nc and minus 10 by 3 Nc. N stands for nano, 10 power minus 9. Are placed at the corners A, B, C and D of square ABCD of side 0.02 meter. What is the potential at the center? Simple question this is. Of course in second PUC it might be a big question for 5 mark. Let me put a simple diagram. Say I am given A, vertex B, C and D. Here I am given 2 by 3 NC only for understanding. This much is not required. This is minus 8 by 3 NC. So here we have 2nc, the other one is minus 10 by 3 nc. Side of the square is given as 0.02 meter. So this side is given as 0.02 meter. This much is given. Now center, from any vertex to center, you find out what is the distance. This distance you have to find. So center is equidistant from our vertices. So center I will make it as O. So in mathematics we learned length of diagonal of a square is equal to root 2a. A is nothing but side. Here side is given as 0.02. So this is equal to root 2 times 0.02. This is the length of diagonal of the square. I require half the length of the diagonal, that is AO is equal to BO, that is also equal to CO, that is also equal to DO. That is nothing but half length of diagonal. Half the length of diagonal in my diagram, it is equal to AO, that is equal to BO, that is equal to CO, that is equal to DO. That is equal to half of this one, root 2 times 0.02. Now this can be written as 2 cancels, so you will have 0.01. I write it as 2 into this one is root 2. So when you cancel it, you will get 0.01. 0.01 I will writing as 10 power minus 2 meter. So this is half the length of the diagonal what we have. Now come back to the last line of the problem. The potential at the center is required. Potential formula is known to us. Potential we recall the formula 1 by 4 pi epsilon naught Q by R, distance. So 1 by 4 pi epsilon naught Q by R. Q is the charge. R is the distance of the charge from the point where we are finding the potential. Let us see. At point O, what is the potential contributed by A? Same way, what is the potential at O due to charge at B, charge at C, charge at D. So find the potentials individually, then you have to add. This we will do it in second QC. Here it is not possible. So potential when you write 1 by 4 pi epsilon naught for all these 4 charges, you get 1 by 4 pi epsilon naught as a common term, put it outside, then Q by R. Even if you observe in this problem, R, the distance of these charges from the center is also the same. Only the charges are different. So therefore I write potential V is equal to 1 by 4 pi epsilon naught R. This much is common, you can take it. Now you take the sum of the charges, charge at A plus charge at B plus charge at C plus charge at C. That's all. Substitute the values. So V is equal to 1 by 4 pi epsilon naught. The value is 9 into 10 power 9. R is the denominator. So R is nothing but the distance from O to D, O to A, O to B in availability. That is nothing but root 2 into 10 power minus 2. So QA. Charge at A is 2 by 3 per body. So for all these charges, nanocoulomb is given. Nano is 10 power minus 9. We can put it outside. So I put 10 power minus 9 common from all these charges. Put it outside. So ignore QA na 2 by 3 work ಮಾಡಿದ್ದೀನಿ. So ಇಲ್ಲಿ minus 8 by 3 ಬರುತ್ತೆ ಇದಕ್ಕೆ. QC ಬಂದು plus 2nc ಅಂದ್ರೆ 2 ಬರ್ಕೊಂಡಿದ್ದೀನಿ 10 power minus 9 is outside. D ಗೆ charge at D minus 10 by 3 ಇದನ್ನ ಹಾಕೊಳ್ಳಿ. ಈಗ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ. ಸಿಂಪ್ಲಿಫೈ ಮಾಡೋಕ್ಕೆ ಒಂದು ಜಸ್ಟ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. ಸೊ ಇಲ್ಲಿ ಬರೀತೀನಿ ನಾನು. ಸೊ ಇಲ್ಲಿ 10 power 9 10 power minus 9 ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. 9 by root 2 ಹೀಗೆ 9 by root 2 ಈಗ ನೋಡೋಣ. ಸೊ ಇಲ್ಲಿ 10 power minus 2 bring it up. That gives us 10 power 2. And 9 into 10 power 2 will be there in the numerator. So ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀರಾ LCM ತಗೊಳ್ಳಿ 3 ನ. ಸೊ ಆಗ numerator 2 minus 8 ಇಲ್ಲಿ ಬಂದು ನಮಗೆ 6 ಬರುತ್ತೆ plus 6 minus 10. ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ. ಸೊ ಈಗ ಏನು ಮಾಡೋಣ 3 ಇಲ್ಲಿ 2 minus 8 plus 6 ಇಷ್ಟು ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ minus 10 ಬರುತ್ತೆ. ಸೊ ಈ ಮೈನಸ್ ನ ಹಾಕೊಂಡು ಹೊರಗಡೆ 10 into 10 power 2 ಅದು 10 power 3 ಆಗುತ್ತೆ. ಇಲ್ಲೊಂದು 3 ಇದೆ ಮೈನಸ್ ಇಲ್ಲಿ 3 ಇದೆ 10 power 2 into ಇಲ್ಲಿ 10 power 3 ಆಗುತ್ತೆ ರೈಟ್ 10 power 3 ಡಿವೈಡೆಡ್ ಬೈ ರೂಟ್ 2. ಸೊ ನೆಗೆಟಿವ್ ಸೈನ್ ಬರ್ತಿದೆ ಪೊಟೆನ್ಷಿಯಲ್ ಗೆ. ಸೊ ಪೊಟೆನ್ಷಿಯಲ್ ನೆಗೆಟಿವ್ ಇರೋದು ನಮಗೆ ಆಪ್ಷನ್ ಸಿ ಆಪ್ಷನ್ ಡಿ ಅಲ್ಲಿ ನ್ಯೂಮರಿಕಲ್ ವ್ಯಾಲ್ಯೂ ಕಂಡುಹಿಡಿಯಬೇಕು. ಬಹಳ ಸಿಂಪಲ್ ಇಲ್ಲಿ ನೋಡ್ಕೊಳ್ಳಿ. ಸೊ ಈಗ ನಮಗೆ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ಎರಡರಲ್ಲಿ ರೂಟ್ 2 ಇಸ್ ಗಿವನ್ ಅಂದರೆ ನಾವು ಮೈಂಡಲ್ಲಿ ಮಲ್ಟಿಪ್ಲೈ ಆ್ಯಂಡ್ ಡಿವೈಡ್ ಬೈ ರೂಟ್ 2. ಸೊ ಅಲ್ಲೇನಾಗುತ್ತೆ -3 ರೂಟ್ 2 ಡಿವೈಡೆಡ್ ಬೈ ಇಲ್ಲಿ 2 ಆಗುತ್ತೆ ಇಂಟು 10 ಪವರ್ 3. ಸೊ 10 ಪವರ್ 3 ನಾನು ಏನು ಮಾಡ್ತೀನಿ 1000 ಅಂತ ಬರ್ಕೊಳ್ಳಿ, ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ. ಸೊ ಈಗ 1000 ಆದರೂ ಬರ್ಕೊಳ್ಳಿ, ನೀವು ಹೇಗೆ ಬೇಕಾದರೂ ಬರೀರಿ. ಸೊ ಇದು 500 ಆಗುತ್ತೆ. 500 ಇಂಟು 3 1500 minus 1500 root 2 ಬರುತ್ತೆ. ಇದು ಆನ್ಸರ್. ಸೊ ಆಪ್ಷನ್ ಸಿ ಇಸ್ ಆನ್ಸರ್ ಫಾರ್ ದಿಸ್ ಕ್ವೆಶ್ಚನ್. ಸ್ವಲ್ಪ ದೊಡ್ಡದಾಗಿ ಕಾಣುತ್ತೆ, ನೀವು ಸ್ವಲ್ಪ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿದ್ರೆ ಫಾಸ್ಟಾಗಿ ಮಾಡ್ಬೋದು ಇದು. ಕಮ್ ಬ್ಯಾಕ್ ಟು ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್. 3 point charges of 0.67 NC, 0.27 NC and 0.35 NC are placed at the corners A, B and C of a square ABC. Find what charge we must place at corner D so that the net potential in the center of the square is 0. Just we'll see how this problem goes. It's a very simple problem. Say we are given A, B, C, D. 4 corners are given. At D, what charge you have to place in order to make the potential at the center of the square 0? Potential formula is known to us. V is equal to 1 by 4 pi epsilon naught Q divided by R. R is the distance. So here the distance from center to A, center to B, center to D, center to C, they are all equal. So AO is equal to BO is equal to CO is equal to DO. So therefore I can take out the distance is also a common term. Net potential is 0. So net potential V is equal to sum of the potentials. Sum of the potentials is nothing but potential at O due to A plus potential at O due to B, potential at O due to C, potential at O due to D. This is given as 0. That means potential of the first charge, if I write it 1 by 4 pi epsilon naught. R is also the same for all charges. Therefore I take 1 by 4 pi epsilon naught R. So R is nothing but this distance. So I will take distance from center to corner is R. Now you add the charges. Charge at A is given as 0.67 NC plus charge at B is given as 0.27 NC plus charge at C is given as 0.35 NC plus charge at D, which we are supposed to find out. I will take a QNC. This is QNC because you can add terms only if they are of same units. Then only we can add them. Now the resultant potential, so the net potential at the center of square is 0 is given. So I made it 0. Bring this complete term to left hand side 0 into this much becomes 0 itself. Now we have Q is equal to Q I retain. The rest of things you transfer them. Add these 3 charges. When they move to right hand side, they become negative. 0.67, 0.27, 0.35, and this is 19, 4, 6, 12, 1.29. So 1.29 NCA is the answer along with negative sign. So that exists in option B. So B is answer for this question. Now I take the next question. In the next question, 2 positive point charges of 12 microcoulomb and 8 microcoulomb are placed at a distance of 0.1 meter in air. What is the work done to bring them 0.04 meter closer? Let us understand what is the given problem. Say I am given 2 point charges. Initially they are separated by 0.1 meter. Now the 2 charges, of course one charge is 12 microcoulomb, another one is 8 microcoulomb. In the next line it says they are placed at 0.06 meter. So find the work done to bring them 0.04 meter closer. 0.04 meter closer andre ಈಗ ಅಷ್ಟು ಹತ್ರ ತಗೊಂಬಂದ್ರೆ ಉಳಿದಿರೋ ಡಿಸ್ಟೆನ್ಸ್ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಅಂದರೆ 0.10 ಅಲ್ಲಿ 0.04 ನಲ್ಲಿ ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿದ್ರೆ 0.06 ಮೀಟರ್ ಬರುತ್ತೆ. ಅಂದರೆ now the distance between the 2 charges is just 0.06 meter. ಇಷ್ಟೇ. ಸೊ ಇಲ್ಲಿ 8 ಮೈಕ್ರೋಕೂಲಂಬ್ ಇಲ್ಲಿ ಬರುತ್ತೆ, ಇಲ್ಲಿ 12 ಮೈಕ್ರೋಕೂಲಂಬ್ ಇಲ್ಲೇ ಇರುತ್ತೆ. ಇಷ್ಟೇ. This is the distance. So distance between 2 charges are 0.06 meter. So 0.06 meter. So initial distance is 0.1 meter, final distance is 0.06 meter. What is the work done? Work done is equal to change in potential energy. Bada simple. So work done is equal to change in potential energy. Potential energy ನಮಗೆ equation ಗೊತ್ತಿದೆ. Potential energy between two point charges separated by distance r. Second PUC. U is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by distance between the two charges. Here, what is the initial potential energy? What is the final potential energy? Take the difference between those two. That difference is equal to work done. So andre first U1 ಕಂಡುಹಿಡಿಯಬೇಕು, next U2 ಕಂಡುಹಿಡಿಯಬೇಕು. ಆ ಡಿಫರೆನ್ಸ್ ತಗೊಂಡ್ರೆ ಬರುವಂತಹದೇ ನಮಗೆ ವರ್ಕ್ ಡನ್. ಇಷ್ಟು ಮಾಡೋಕೆ ನಮಗೆ ಸೀಟಿಲ್ ಟೈಮ್ ಇಲ್ಲ, ಡೈರೆಕ್ಟ್ ಆಗಿ ಮಾಡ್ಕೋಬೇಕು. ವರ್ಕ್ ಡನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು, ಈಗ ನಾವು ಡಿಫರೆನ್ಸ್ ತಗೋಬೇಕಾದ್ರೆ ಈಗ ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕು. ಈ ಈಕ್ವೇಷನ್ ಅಲ್ಲಿ 1/4πε0 Q1 Q2 ಅದು ಕಾಮನ್ ಇರುತ್ತೆ ಎರಡು ಈಕ್ವೇಷನ್ಗಳಲ್ಲಿ. ಓನ್ಲಿ ಡಿಸ್ಟೆನ್ಸ್ ಇಸ್ ಬೀಂಗ್ ವೇರಿಡ್. ಇಷ್ಟನ್ನ ನಾನು ಹೊರಗಡೆ ಹಾಕ್ತೀನಿ. 1/4πε0 Q1 Q2 ಕಾಮನ್ ಟರ್ಮ್. ಈಗ ಇನಿಷಿಯಲ್ ಡಿಸ್ಟೆನ್ಸ್ ಬಂದು 0.1 ಮೀಟರ್ ಇದೆ, ಅದನ್ನು ಹಾಕೊಳ್ಳಿ. 1/r1 ಅಂತ ಬೇಕಾದ್ರೆ ಹಾಕೊಳ್ಳೋಣ ಒಂದು ಸ್ಟೆಪ್ ಅಲ್ಲಿ. ಮೈನಸ್ 1/r2 ಅಂದ್ರೆ ಇದು ಯಾವುದು ಕಡಿಮೆ ಇದ್ರೆ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಎಲ್ಲ ವ್ಯಾಲ್ಯೂಸ್ ಪಾಸಿಟಿವ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಇಲ್ಲಿ. ಸೊ ಇದರ ತಗೊಂಡ್ಬಿಟ್ರೆ ನಿಮಗೆ ನೆಗೆಟಿವ್ ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ, ಏನು ಗಾಬರಿ ಆಗೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಪ್ಲಸ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ರೆ ಸಾಕಿಲ್ಲ, ಯಾವುದು ಕೊಟ್ಟಿಲ್ಲ ಆ ಥರ. 1/r1 ಮೈನಸ್ 1/r2. ಈಗ ನಾವು ನೆಗೆಟಿವ್ ಸೈನ್ ಅವಾಯ್ಡ್ ಮಾಡಬೇಕಂದ್ರೆ ಫೈನಲ್ ಡಿಸ್ಟೆನ್ಸ್ ನ 1/r2 ತಗೊಳ್ಳೋಣ. ಇನಿಷಿಯಲ್ ಡಿಸ್ಟೆನ್ಸ್ r1. ಸೊ ನೆಗೆಟಿವ್ ಸೈನ್ ಅವಾಯ್ಡ್ ಮಾಡಬೇಕಂದ್ರೆ ಫೈನಲ್ ಡಿಸ್ಟೆನ್ಸ್ ಇಲ್ಲಿ ನಮ್ಗೆ r2 ಇದೆ. ಸೊ ಇಲ್ಲಿ r2 ತಗೊಂಡ್ರೆ ಇದು r1 ಆಗುತ್ತೆ. ಸೊ ಈ ಈಕ್ವೇಷನ್ ಅಲ್ಲಿ just to substitute 1/4πε0 is 9 into 10 power 9. Q1 Q2. Q1 ಎಷ್ಟಿದೆ? 12 microcoulomb. 12 micro is 10 power minus 6. ಇದು ಇನ್ನೊಂದು 8 microcoulomb. ಸೊ 8 microcoulomb ಗೆ 8 into 10 power minus 6 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. 8 into 10 power minus 6. 1/r1 1/r2 ನೋಡೋಣ. r1 is 0.1 ಮೀಟರ್ ಇದೆ. ಸೊ 1r1 ಗೆ 1/0.1 ಇದೆ. r2 ಗೆ 0.06 ಇದೆ. ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಇಷ್ಟೇ. ಇದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಬೇಕು. ಇಲ್ಲಿ ಹೊರಗಡೆ ನೋಡಿ 9 into 12 into 8 ಒಂದು ಕಡೆ ಬರೋಣ. 9 into 12 into 8 10 power 9 10 power minus 6 10 power minus 6 add the powers. ಇದು minus 12 plus 9 10 power minus 3 ಇರುತ್ತೆ. ಇಲ್ಲಿ ನೋಡೋಣ, ಈ ಥರ ಸಿಂಪ್ಲಿಫೈ ಮಾಡೋದು ಡಿಫಿಕಲ್ಟ್ ಇದೆ. ಸೊ ನೀವೇನು ಮಾಡ್ತೀರಾ, ಮೈಂಡಲ್ಲಿ ನಾವು ಮಲ್ಟಿಪ್ಲೈ ಆ್ಯಂಡ್ ಡಿವೈಡ್ ಬೈ 100. ಸೊ ಇದು 100/6 ಅಂತ ತಗೋಬೋದು. ಅದೇ ತರಹ ಇಲ್ಲಿ ಮಲ್ಟಿಪ್ಲೈ ಆ್ಯಂಡ್ ಡಿವೈಡ್ ಬೈ 10 ಮಾಡಿ ಮೈನಸ್ 10/1 ಆಗುತ್ತೆ. ಇದು ಈಸಿ ಆಗುತ್ತೆ ನಿಮಗೆ. ಸೊ ಈಗೇನು ಮಾಡೋಣ, ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ಗೆ ಇಲ್ಲಿ ಬರೆಯೋಣ. 9 into 12 into 8 into 10 power minus 3 ಇದೆ. ಈಗ ಇಲ್ಲಿ ನಾವು LCM ನ 6 ತಗೊಳ್ಳೋಣ. ನ್ಯೂಮರೇಟರ್ ಇಲ್ಲಿ ಬರೋ ಒಂದು 100 ಬರುತ್ತೆ, ಮೈನಸ್ ಅಲ್ಲಿ ಬಂದು 60 ಬರುತ್ತೆ. ಭಾಳ ಈಸಿ ಆಯಿತು. ಈಗ 6 2 ಟೈಮ್ಸ್. ಈಗ 9 into 2 18. 2 into 8 2 into 8 16 16 into 9 144 into 10 power minus 3 ಇದೆ. ಇಲ್ಲಿಂದ 100 minus 60 is nothing but 40. ಸೊ ಈಗ ನೋಡೋಣ, ಈಗ 150 ಅಂತ ತಗೊಳ್ಳೋಣ. ಸೊ 150 into 4 ಮಾಡ್ಕೊಳ್ಳೋಣ. ಸೊ ಈ 10 power minus 3 ಇಲ್ಲೊಂದು 10 ಹೊರಗಡೆ ತಗೊಂಡ್ಬಿಡಿ. 40ನ ನೀವು 4 into 10 ಅಂತ ಬರ್ಕೋಬೇಕು. 10 power minus 3 into 10 is nothing but 10 power minus 2 ಬರೀತೀನಿ. ಇದನ್ನು ಸುಮಾರಾಗಿ 150 ತಗೊಳ್ತೀನಿ. 150 ಇಲ್ಲೊಂದು 4 ಇರುತ್ತೆ, ಅಂದರೆ 600 ಬರುತ್ತೆ. 100 into 4 ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ. ಎಕ್ಸಾಕ್ಟ್ ಮಾಡ್ಕೊಂಡು ಹೋಗೋಕ್ಕೆ ನಿಮಗೆ ಟೈಮ್ ಇದ್ರೆ ಮಾಡ್ಬೋದು. ಎಕ್ಸಾಕ್ಟ್ ಮಾಡಬೇಕಾದ್ರೂ ಮಾಡಬಹುದು. ಅಕಸ್ಮಾತ್ ನೀವು ಇದನ್ನು ನೆಕ್ಸ್ಟ್ ನಂಬರಲ್ಲಿ ಇಲ್ಲಿ CET ನಾವು ಮಾಡೋಕ್ಕಾಗಲ್ಲ. 144 ಇದನ್ನು 4 ಅಂತ ಇಟ್ಕೊಂಡು 10 power minus 3 ಇದನ್ನು 10 power minus 2 ಹಾಕೊಳ್ಳಿ ಸಾಕು. ಇದು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ. 4 into 4 is 16 4 into 4 16 170 576 576 into 10 power minus 2 ಬರುತ್ತೆ. ಇದು 5.76 J ಇದೆ. ಸೊ ಇಲ್ಲಿ ನಾವು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ಆಪ್ಷನ್ ಡಿ ಅಲ್ಲಿ 5.76 ಇದೆ. ಅದು ಆನ್ಸರ್. ಭಾಳ ಬೇಕಾಗಿ ಮಾಡಬೇಕು, ಮಾಡಬಹುದು. ನೀವು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಬೇಕು ಇದರ ಪ್ರಾಬ್ಲಮ್ನ ಈಸಿಯಲ್ಲಿ. ಇನ್ ವೆರಿ ಶಾರ್ಟ್ ಟೈಮ್ ಯು ಕ್ಯಾನ್ ಡೂ ಇಟ್. Now coming back to the next question, a hollow charged metal sphere has a radius r. If the potential difference between its surface and a point at a distance r from its center is d, find the electric field at a distance r from its center. Normal method if you apply, ಈ ಪ್ರಾಬ್ಲಮ್ಗೆ ಜಸ್ಟ್ ಬೇಕಾಗಲ್ಲ ವಾಟ್ ಇಸ್ ದ ಈಕ್ವೇಷನ್ ಫಾರ್ ಪೊಟೆನ್ಷಿಯಲ್. on the surface of the sphere or away from the surface of the sphere. V is equal to Q by 4 pi epsilon naught R. So if R is equal to capital R radius, here it's given as R itself. So this is the potential of the sphere. So R maybe any value away from the surface. Now we are given in the problem 2 points. One point is taken at a distance r from the center. Another one is of course on the sphere itself. V is marked as the potential difference between the potential at a point distant 3r from the center and potential on the surface of a sphere. So in V is nothing but potential difference. So difference in potentials. So one point is taken at a distance 3r. The potential at a point distance 3r is 1 by 4 pi epsilon naught q divided by 3r. Potential on the surface is q by 4 pi epsilon naught r. This difference is taken as V. Then simplify. Q divided by 4 pi epsilon naught r I take as common. Here I will take coefficient 1. There it is 1 by 3. Simplify this. So I get Q by 4 pi epsilon naught r. 1 minus 1 by 3 is nothing but take LCM 3. 3 minus 1 you get 2 by 3. This is a potential difference between a point which is at a distance 3r and the surface. Any point to take on the surface. Now what is asked? Electric field at a distance Pr from its center. Electric field equation ಗೊತ್ತಿದೆ. So E is equal to 1 by 4 pi epsilon naught Q divided by distance square. Distance is 3r square. ಇಷ್ಟೇ. ಇದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ. This is equal to 1 by 4 pi epsilon naught Q divided by r square. 3 square is nothing but 9. ಯಾವಾಗಲೂ ಚೇಂಜ್ ಮಾಡಿ. So just observe this. ನಾನು ಏನು ಮಾಡ್ತೀನಿ 1 by 4 pi epsilon naught q ನ from this equation I replace it. 1 by 4 pi epsilon naught q. This much I replace it. ಇಷ್ಟು replace ಮಾಡಿದ್ರೆ from this equation. So I can write q by 4 pi epsilon naught. Send this v to right on the other side. That becomes 3v. R also send it right side. So 3rv r3 3rv divided by 2 is equal to this one q by 4 pi epsilon naught. ಇದನ್ನು replace ಮಾಡಿ. This is equal to 3rv divided by 2. This much is replaced. 1 by 9r square is there. 1 by 9r square. Simplify ಮಾಡಿ. Cancel 1r. 3 times. So you get v by 3 into 2 is 6r. v by 6r. So this might be there in option A. So A is answer for this question. So this is one method. Another method is also there. So if you remember the formula for electric field and electric potential in terms of sigma, that might be a bit easier. So you have to learn additional formula, then it becomes a bit easier. Otherwise there is a normal method what I have done. It can be done in a very short time. Now we'll take the next question. In the next question, we are given to 3 protons which are separated by distance of 10 power minus 10 meter. They are released. So they are at a distance of 10 power minus 10 meter. When they are released, what is the kinetic energy of each proton when they are at infinite distance? So infinite separation means there won't be any potential energy between them. That's all it is. Now you find out what is the initial potential energy between the 2 protons when they are at a distance of 10 power minus 10 meter. That potential energy will be shared equally between the 2 protons. That energy, whatever they get, is nothing but the kinetic energy. So kinetic energy of each proton is equal to half of the initial potential energy. So this is the concept what we have. So in kinetic energy, just kinetic energy is equal to half of initial potential energy. That's all it is. This is equal to half initial potential energy. Formula potential energy formula is known to us 1 by 4 pi epsilon naught q1 q2 divided by distance r. Just to substitute all the things. So this is equal to 1 by 2. 1 by 4 pi epsilon naught is 9 into 10 power 9. Q1 is charge on proton. Charge on proton 1.6 into 10 raised to minus 19. One more Q2 is charge of another proton. that is also 1.6 into 10 power minus 19 divided by distance r. Distance r is here it is given 10 power minus 10 meter. Simplify this. So 10 power minus 10 you bring it up, that becomes 10 power 10, 10 power 9 joining with 10 power 10, that becomes 10 power 19. That I cancel with 10 power minus 19. That means this much I will cancel it. Remaining things will simplify. Now this 2 into this is a numerator, I have 9 into 1.6 by 2, I read it as 0.8. Here I am left with 1.6. 10 power 9 minus 19 is also there. That's how we have to do it. Now this 9 into 16, if I take it 144, now this becomes 14.4 into 0.8 we have to do it. So if you do this, so 8 into 4, 32, 8 into 4, 32 plus 3, 35, 8 into 1, 8 plus 3, 11. So this gives us 11.5. So approximately this is 11.5 into 10 power minus 19 J. This is answer. So this is available in option B. So B is answer for this question. So with this I end today's session. Subscribe to the channel. Turning Point classes. Share the video with your friends. Like the video. Come back to the next session with a few more questions. God bless you.